Discrete time system H1n and H2n are connected in cascade. H1n is 1 by 2, 1 by 4, 1 by 2. H2n is delta of n minus 2. Then determine the response of overall system to input xn is equal to delta of n plus 2 plus 3 delta n minus 1 minus 4 delta n minus 3. So we write here given H1 of n is equal to 1 by 2, 1 by 4, 1 by 2, and H2 of n is delta of n minus 2. Since H1 and H2n are connected in cascade, we write here, since the problem was asked for 8 marks, since H1 of n and H2 of n are connected in cascade, then according to associative property of convolution, total impulse response is H of n is equal to H1 of n plus convolution H2 of n. Now we have the property of convolution. So x of n delta of n minus k is equal to x of n minus k. So h of n is equal to h1 of n into delta of n minus 2 h1 of n minus 2. So h of n, it is 0, 0, 1 by 4, 1 by 2. Now hz is equal to summation n goes from 0 to 4 hn z raised to minus n, that is equal to h of 0 z0 plus h1 z raised to minus 1 plus h2 z raised to minus 2 plus h3 z raised to minus 3 plus h4 z raised to minus 4. So we can write this equation as 0 plus 0 plus we substitute values of h of 0, h of 1 here. So 1 by 4 plus 1 by 2, this is equation 1. Now given input is xn is equal to delta of n plus 2 minus 3 delta of n minus 1 minus 4 delta of n minus 3. So x of z is equal to z square minus 3z raised to minus 4z raised to minus 3. Now we have hz is equal to yz divided by x of z. So we can write yz is equal to hz into x of z. So we substitute values here, plus 1 by 4 plus 1 by 2 into z square minus 3z raised to minus 4z raised to minus 3. So y of z is equal to, now we multiply these two bracket and solve it. Here I write the final after solving. Here I write the answer of solving the answer what we get after solving these two brackets, multiplying these two brackets. So it is z raised to minus 2 minus 3 by 2 minus 7 by 2 minus z raised to minus 6 minus 2 z raised to minus 7. Now taking IZD, take IZD, that is inverse Z transform y of n is equal to plus 1 by 4 plus 1 by 2 minus 3 by 2 delta of n minus 3 minus 3 by 4 delta minus 4 minus so y of n is equal to 1 by 2 1 by 4 1 by 2 by 2 by 4 this is the response of overall system. Now next problem, LTI system is described by Hn is equal to 0.9 raised to n un. Then plot magnitude response of system using analytical method. So we write here given h of n is equal to 0.9 raised to n u of n. Now we have standard Z transform. We have standard Z transform pair as a raised to n u of n. It is z by z minus a. ROC is now here a is equal to 0.9, so h of z is equal to z by z minus 0.9. So h of z is equal to 1 by 1 minus 0.9 z raised to minus 1. Now h of omega is obtained by putting z is equal to e raised to j omega in equation 1. So h of omega is equal to 1 by 1 minus 0.9 to minus j omega. So 1 minus 0.9, it is cos omega minus j sin omega. So again it is 1 minus 1.9 cos omega minus 0.9 sin omega. Now this is h of omega. Now next is its magnitude. So it is 1 divided by square root of 1 minus 0.9 cos of omega square plus 0.9 sin of omega square. So after solving, the equation is, it is 1 minus 1.8 cos omega plus 0.81 cos square omega plus 0.81 sin square omega. Again it is 1 divided by square root of 1 minus 1.8 cos of omega plus 0.81 is common, taken outside, cos square omega plus sin square omega. Now cos square plus sin square is 1. So the equation is 1 divided by square root of 1 minus 1.8 cos of omega plus 0.81. So this value is 1. It is 1 divided by square root of 1 minus 0.81 cos of minus pi plus, now here we write for, it is magnitude, for omega is equal to minus pi. We substitute this value in this equation. It is 0.81. So the answer is 0.52. and for omega is equal to minus pi by 2. So it is 1 divided by square root of 1 minus 0.81 cos of minus pi by 2 plus 0.81, it is 0.743. Now next is for omega is equal to 0, answer is 1 divided by square root of 1 minus it is 1.8, sorry, it is 1.8, it is also 1.8, not 0.81. So it is 1 minus 1.8 cos of 0 plus 0.81 equal to 10. So this value is 10. Now for omega is equal to pi by 2, we substitute these values and we get answer h of omega is 0.743, and for omega is equal to pi we get the answer 0.52. So for that we draw the graph here. This is omega, this is magnitude, here it is 0, here it is pi by 2, pi minus pi by 2, pi, it is 0.52 and it is 0.743, here it is 10. So the graph is like this. Next problem, find the magnitude and the phase response of given system at frequency omega equal to 0 and omega equal to pi. Given system is hz is equal to 1 by 1 minus 0.5 z raised to minus 1. Now the magnitude response is obtained by putting z is equal to e raised to plus j omega. So h of e raised to j omega is equal to 1 by 1 minus 0.5 raised to minus j omega. This is equation 1. But e raised to minus j omega is equal to cos of omega minus j sin omega. So h of e raised to j omega is equal to 1 by 1 minus 0.5 cos omega minus j sin omega, that is equal to 1 by 1 minus 0.5 cos of plus 0.5 j sin omega. This is equation 2. So it is 1 divided by square root of 1 minus 0.5 cos omega square plus 0.5 sin omega square. It is again 1 minus cos omega plus 0.5 square cos square omega plus 0.5 square sin square omega. So 1 minus cos omega plus 0.5 square is common, taken outside, in bracket it is cos square omega plus sin square. So this value is 1. So the 1 minus it is 1 divided by 1 minus, this is 0.25 plus point minus cos of omega. This is equation 3. Now therefore at omega is equal to 0, at omega is equal to 0, h of e raised to j omega is 1 by square root of 1 plus 0.25 minus 1, this value is 2, and at omega is equal to pi, it is h of e raised to j omega 1 divided by square root of 1 plus 0.25 minus cos pi. So this value is 0.66. Now from equation 2, angle e raised to j omega is equal to tan inverse of 0 minus tan inverse of we have to find the angle values for all these. It is tan inverse of 1 minus 0.5 cos of 0. So this value is 0, and at omega is equal to pi, this angle is tan inverse of so this value is also 0.